Hey there, and good morning. This is Into the Terminal, and I'm one of your hosts, Eric the IT Guy. And joining me today is
Scott McBrien.
the king of our APAC session, and today we're going to be talking about service administration. So we'll bring up our lab machine that we've been working on the last few days, and today we're going to talk about how do you actually manage processes within Linux. We've created users, we've managed files, we've installed some packages. So now let's start actually administering some of those packages. So if I'm not mistaken, Scott, we went ahead and installed Apache Web Server. So it's a package called HTTPD. And so one of the first things we want to do is let's check on the state of Apache. So a lot of our system services are managed through a command called systemctl. Excuse me, I apologize. Systemctl is the command that we use to manage a lot of our processes. So we want to start with a systemctl status, and that'll tell us the status of our service. So it's command, it's what action you want to take, and then what service. So in this case, it's HTTPD. So if we look at the active line about 3 lines down, it tells us that the process is inactive. So that means that the Apache Web Service is installed, and we can assume in today's example that it's properly configured. So from there, let's go ahead and instead of status, let's do a start to get our web server running. So systemctl start HTTPD. And then if we do a status on it again, in Linux, a lot of times no news is good news. And as you can see here, there's multiple processes running, all managed by the system, all managed by the HTTPD service, as well as a few clips from the log file, so you can kind of see what the process is doing. Scott, you want to you have anything to add on that one?
The big thing I think is that it's active and running, so that's good. If we started it up and it didn't work out well, that would probably be a different status, like failed or something along those lines. And when it is failed, that snippet of logs down at the bottom, really handy.
Yeah, it's great. Sometimes it's something simple like the process didn't end cleanly, so you could do a stop or a kill, and then do a restart, and you don't have to leave the systemctl command. So there's actually a catch to using the start option on processes. If we were to reboot the server right now, the Apache process would actually not start on reboot. So the third command we want to cover in the opening segment is the enable option. So if we do a systemctl enable and then our Apache web server, so HTTPD, and hit enter, we'll see that it actually created a symlink within the etc systemd directory tree, which basically says that this service is now flagged to start on boot. So if we were to reboot our system right here and log back in, we'd see systemctl status, and HTTPD would actually be running. We won't do that because then Scott did it anyway. All right, well, that's
it's a
rebooting.
live demo. What could possibly go wrong?
Nothing ever. All right, well, that system is rebooting. Let's go ahead and jump into the next segment. Mr. McBrien, how's it going?
Doing good. The Into the Terminal After Dark edition is going well. So for anybody who likes watching things or seeing just Scott and no Eric, which is sadness, but filter on. After Dark is where it's at.
I think I'm changing the YouTube videos now. It'll be Into the Terminal After Dark, and we may get flagged, but it'll be funny.
So that system is back up from its reboot,
Awesome.
by the way.
Okay,
So
let's
shall
go
we
ahead
see
and
if the live demo actually worked?
Right. Yeah. Let's see if our HTTPD process is still running.
Yay!
What do you know? Live demo actually worked. So, Scott, do you want to talk a little bit more about what processes are and get into how those interact with different layers of the boot process?
Sure. That's a very broad swath there. Um, let's start by just talking about like a process is simply an organization through which we can track resources and programs running on the system. Right. And I know that in a bit we'll talk about a command called process status so that we can see all the processes running on the system. But what we did during the first segment of the show was really look at daemons and services. Right. So these are things offered by our machine to either other applications running on the machine, or more likely things outside the machine, right? So, for example, Apache, because we enabled and started that service, we can now serve web pages to people outside of our system. What is a daemon? A daemon is a process that runs that is not bound to a terminal, right? So, like when we're interacting with the terminal running commands, it accepts input, provides output. Well, daemons aren't bound to a terminal, so it doesn't do those things. So typically they're hooked into places like logs so that we can get information about what they're doing. And then when we were using systemctl, we were starting and stopping them, right? Because they're not attached to a terminal. How do we run them? How do we kill them? So the systemctl command is how we do that control. And then a lot of the times we want those services to be offered at boot time on the machine, which is why we use the systemctl enable so that as our machine comes up, those also initialize and become available.
So, very important question: is it demon or daemon?
Um, I've heard it pronounced both ways. Um, like tomato, tomato, potato, potato, Eric, Ark. So,
Yeah, our boss loves to call me Irk. So you mentioned a command that would actually tell us what processes are running, and to be honest, I didn't know what it meant, but that was of course the PS command.
Yeah, so if we just run PS by itself, it shows me the running processes in the current shell. So when I run PS, it's like, oh, there's a bash shell running in the shell, and the PS command was running in the shell. So not super useful. And as a result, we often will see PS used with a combination of options. So I like PS AUX. So PS A says all processes, not just mine. U, show me the username that goes along with these processes. And X, show me those processes even without a controlling terminal. So I'll get to see things like the daemon processes. And so much larger list. And what we see is we get the user that owns the process, its unique process ID number. We get a little bit of information about its system utilization. So that's like percent CPU, percent memory, if I remember correctly. The actual amount of memory that's been allocated. The next field is the resident memory. So that's the memory that it's claiming is residence in RAM. Over here, the SNS or SNL or SSL, that's the status of the process. So the different letters mean different things. So, for example, this little R down here at the bottom, that means it's running. S means it's
That's sleeping.
traditionally we call it sleeping, but there's actually another name like it's not actively using CPU clock cycles. Let's put it that way.
Right.
The next field over is the length of time that this process has been active on the system. The next one is the amount of CPU time this process has consumed, and then we see the actual process itself over here on the right hand side. And so, a lot of times we'll combine the status also with our friend grep because you don't want to see the like 1,000 different lines. You might only be interested in maybe the web server processes, right? So let's do our PSAUX by putting the grep HTTP. Right. So those are our just the web server processes. And a little pro tip for you: notice that our grep also showed up in that list. If you just put your first letter in square brackets, which changes this from a straight string to a more complex regular expression. Your grep no longer matches the string that it was looking for, and so it doesn't show up in your process status output. So,
That is
pro tip.
incredibly helpful. I actually never figured that out.
Um, so
I'm glad we
that's a little
started
bit
the
on
show.
process status.
I'm glad we started the show. I've learned new things every day. So
Oh,
go
I
ahead.
see somebody has a question about PS in the chat. Um,
Yes.
all right, so
Go
somebody
ahead.
has the same person also has a suggestion for their options for PS. So let me see what they have there. Yes, AEFH. Ooh, maybe I need a dash in front. Yeah, so similar information. The username that owns it, process ID. This is the parent process ID, I believe. I don't know what the zero is. We'd have to look at the header. Let's see up here. Oop, scroll too far. Oh, the CPU it's running on, the system time, if it's attached to a controlling terminal. This would be probably the CPU time, maybe, and then the command on the side. So I mean, there's like literally of options for customizing how we do this. There's one called PS Tree.
We may not have it on this box.
Yeah, I might not have it installed. There's one where it like displays a tree output, so you can see like their actual relationship between parent and children processes. Um, so yeah, there's lots of different ways to skin this cat. Not that
Right.
I could
Like
uh, endorse skinning cats, but
I'm sure that being from Georgia, Scott would have plenty to say on skinning cats, but at least I didn't say anything about Ohio. Inside joke there, but um, before we go too far down that rabbit hole, one thing about PS Tree that I found useful is if you're trying to gracefully stop a process, PS Tree is really nice to be able to see what's going on so you can drill down to that specific process. So if you're doing a system CTL stop and you're not getting a clean exit, sometimes there'll be a process that has entered what we'd call a zombie state or is just not is still doing a cleanup and hasn't completely closed. So PS Tree is a really great way to go in and see what is running, what child processes are running underneath this particular system service that may not be allowing it to gracefully shut down. Which brings up a good point. So let's say our web server has crashed, which happens from time to time, and doing a system CTL stop will not actually close out our web server gracefully, so we can then restart it. So we've got a runaway process. We've got something that's entered a zombie state or something along those lines. Is there a command within Linux that allows me to more forcibly remove that process from an active state?
sure. So we could use a command called kill. So let me pull up that list of HTTPD processes one more time. So we could do something like kill 1232, and that will send a terminate signal to that process ID. So the kill actually sends a whole bunch of different signals. So these are all the potential signals you can send, and when you don't specify, you actually get this one, sigterm. Um, There we go. Sigterm is a terminate signal, and that's the normal way processes are communicated with to ask them to gracefully exit. So when a process receives sigterm, inside that program is maybe some additional steps that it should execute when closing gracefully, and then it goes and kills itself. But there are other signals too, and I think that's probably where you were going with some of this. Let me pull up my list of let's see this one more time. So we killed 1232, and we can see that 1232 is now no longer there, right? So it was successfully terminated.
Yeah, the bash shell can actually be quite violent. I mean, there's cut, there's kill, there's a few others. I used to know a whole list,
Yeah.
but it can get kind of violent. So 1232 responded to our kill command, but I noticed that 1234 is running, and let's say, just for the sake of argument, that it didn't. We tried to do a kill, and 1234 is still there. It just will not die. Short of rebooting my
Wait,
box, is there actually? Go ahead.
is it mocking us?
It is. It is mocking us.
Oh, well, we can't have that. So
So I
for that
mean,
one, we want to use a little bit stronger language for dealing with them. So for a process that is not honoring the terminate signal, right? And that could be because it's like mangled in some way and it is not able to receive that. Or it could be that somebody did something dumb, like when they wrote their application, they actually put in a signal catcher so that when that process was signaled with terminate, it did something different or ignored it entirely, which is not good programming practice, but I've seen it happen sometimes.
ugh.
So this one sends a different signal, signal number 9, and we'll take a look at that list in just a second. And this actually doesn't go to the process. What we're really doing with signal 9 is telling the kernel to go out and take care of this process. So we're telling the kernel to go out and handle process 1234 and do what it needs to do to make sure it's no longer running. So there we go.
So we actually hired the kernel to carry out a hit on this process. That's amazing.
Yeah. Now, you want to use this sparingly though, because it didn't go to the process directly. Like literally, the kernel just cleaves it off the process table and like closes out all of its open memory and stuff. So, like files that this process had open, probably still marked as open. And the kernel will clean that stuff up eventually. Like when somebody else tries to open that file, it'll see that it's open, but the process that holds it open isn't there anymore. So it'll close it and then reopen it for the new thing. Um, but like if that process had file writes it was doing, and you killed it in the middle of doing file writes, then it didn't complete those things and you lost that data. So you want to be sparing when you use kill -9. You really want to use it only in those situations where it's dire. Normally, when something gets the terminate process, like the normal signal that gets sent when you kill it, if it has files that it's writing, it'll finish that stuff up and then close itself out. And so one of the other things I've also seen is you send the kill signal or the terminate signal, and it takes a while, and you might think that it's mocking you and you need to kill -9, and maybe you just need to wait a little bit longer because it was really busy doing stuff to gracefully close itself out. All
So
right, so
if only there were a way that we could see what running processes we're actually doing. Like, is this process just is it just out there? Is it actually writing? Is it actually is there a way where we could actually just live see what's running on our system? Sorry,
there
the puns are getting
is.
worse.
I just wanted to like tie off our Signal 9 discussion here. So when we said kill -9, it was actually sending this guy sig kill, and that's what's having the kernel go and kill it. So I think Eric, what you're looking for is a program we probably don't have installed. So I'm going to go ahead and install it. It's called Trace. All right, and let me pull up my PS one more time. So if we wanted to see what process 1233 was doing, it's been a minute since I've run strace, so I'm hoping that this is the correct syntax. If not, we'll have to look at its help or something. Oh, oh there we go. So we've connected to process 1233, and this one is not active because it's not serving web pages. But so it's sitting there. It's reading its incoming connection socket, waiting for traffic. And it's just going to sit there. And until it actually gets some traffic, it's just going to continue to sit there.
Mm-hmm. This
So let's
strace
maybe
really
look at
comes in
three.
handy when it helps kind of surface what's actually going on. So if it's just sitting there and it's not doing anything, uh, you can tell that maybe you'd expect this process to be actually carrying out like a write operation or something, and if it's just sitting there, then you could reasonably assume that it's hung, and you might have to take it out to pasture. But yeah, let's go ahead and run this, and I'm curious what a dig brings back.
We don't have
Oh, we don't
dig.
have dig.
We gotta have dig. We don't have dig. All right, how about
there is no dig.
weird? We have no DNS tools.
No, I think it's is it DNS utils now?
Maybe.
You
How
you
about we
you
do?
mocked the you mocked the demo gods, and now they're now they're they're coming back at you.
Um, yeah, I mean, live demo. What could possibly go wrong? Then we get a whole bunch of programming libraries.
Right. I
DNS
thought it was under.
mask.
I feel like I just installed this yesterday. Actually, you would be very proud of me. I was playing around in my home lab last night, and instead of doing an RPM-QA, I actually used DNF list available, and it gave me some good information because the package I was looking for was not in the repo that I expected it to be in. So using DNF list available actually told me that, oh, I need to go back to this other system and add that. I think it might have been Apple. It's like, oh, I thought that was a supported package, but it's a community supported package. So
I know a command that we've got that will do the needful. So there we go.
there we go.
It's getting too focused on the syntax and not task I was trying to execute, right? Which is show you the output of an strace. So strace shows you all of the system calls that I program, right? So the first system call is we get an exec, and we're told what command to exec and arguments and things like that. And then it makes a archprctl function call. Then it makes an access to the preloader, and then makes an open at, and it maps some memory with mmap. So what we're seeing is all the system calls that were made and the arguments passed to those system calls when we did this ls. And so when you're looking at a process and you attach strace to a process, that's the kind of data you're going to see.
What's crazy is all of those system calls just to show us the contents of the temp directory. It's amazing how much is going on underneath the hood when you're working on a Linux system. So
Yeah,
strace
and I
was
will say
definitely
that
kind of a 201 level command, but it is good to know that that's there in case that strace doesn't come back with a zero return code, which means it was successful. So if it's hanging somewhere and you'd expect a quick return, you might know that that might clue you into there's other things going on the system that we might have to kill a runaway process, or maybe a disk drive is full. But something like strace on a process would definitely help give you an idea of what the system is actually doing, and if it's doing what's expected. If it is doing what's expected, it may just be taking longer than you might think, or it's doing some cleanup work in the background. Processes do try to clean up after themselves, and then and try to return the system into a good state. So we went to a 201 or a 301 level command there with strace. Let's bring it back to the top. We've got a few more minutes. Let's bring it back to
so I do have
back to the.
you want to see another trick?
Yeah, sure.
All right.
Yeah. This is always fun to mess with people's systems, to use the dd command.
All right. So what I'm doing is I'm just doing a file write to write a file called big file. And there we go. And I'm going to do it was too fast. Let me try it again, but more longer.
Give me all she's got, Captain.
All right, so I'm going to do a kill sig user 1 on process 2757. Sig, sorry, it helps if I spell it right. So when you kill sig user 1 on a DD process, it actually reports where it's at in its writing.
Nice.
So like when you're writing a big file with DD and you're not sure how long it's going to take or where it's at, you can just kill it with sig user 1 and it will pop out a status. So again, all these different signals that you can send to processes. So that would be a kill dash 10, sig user 1 here. That DD has been written with a signal handler, so when it receives sig user 1, it pops out this status. So developers can actually write what we call signal handlers to change what happens when different processes are provided different signals. When you do something like oh, take care of that quick before it crashes the box.
Right.
Um, when you do something like Control Z on a foreground process and it tells you that it stopped, what you're really doing is set 19 here, sig stop, to that process to tell it to just pause in the middle of executing. So you're probably use signals, or Control C is another good example. Control C is actually this one, signal number 2, sigint. When you log out, all of your running programs are given this one, sig hup, to let them know that the user has hanged up on them. Because in the olden days, you would literally like take the phone off the modem and hang it up to terminate your connection with somebody. Yeah, so you've been using signals all along. You just didn't know it because you were using like Control C or Control V, or maybe a system CTL command that was actually using some kind of terminate or something behind the scenes.
Yeah, that's really cool. You stepped on my pun there, Scott. I was talking about how strace was like a 301 level command, and I wanted to bring it back to the top. So the top command is a live, pretty close to live look. I think it refreshes about every 5 seconds as to what your system is actually doing. In fact, there's a fairly popular additional package called HTOP, which is a little bit more graphically designed and it's color coded. That I use a lot of times. It breaks out all of your CPU cores so you can see which cores are running hot. It breaks out your RAM so you can see how full your RAM is. But just looking at the top command, it tells us how many users are logged into the system, how long this box has been running. Our load average, which breaks down in 1, 5, and I think 10-minute increments, how much of a load our system has been under.
15.
Oh, is it 15?
And the other, yeah, and then the other thing with that one is that it actually is a process count that has been logged. And by logged, I don't mean like writing into a log file. I mean the mathematical function logarithm, so that there's smoothing of any spikes that may have happened during those sample periods of 1, 5, and 15 minutes. So it is not an exact number. It is an indicator.
Right. Yeah, and don't ask me to explain the logarithm. I knew enough about logarithms to get through Algebra 1 in college, and then I got to take a statistics class for my second math credit. So definitely not my strong suit, but just know it is an average load balance or load average. It is a load average, not a true representation. Um, so going down to line number 2, we can see how many tasks are actually running, or how many tasks total there are, how many are in a running state that is actively using system resources. Then there's others that are sleeping, like we mentioned before, that are just kind of waiting for an action to take place. In the case of our web server, it's just waiting for someone to come to the server's URL to tell you or to actually access the website and interact with the text on the screen and whatnot. There is a readout on memory usage or swap usage, and then again our CPU state. So if we look down at the next section, there is you can see the process ID, the user. So the output is very similar to that of the PS command. However, you'll notice that it's actually refreshing every few seconds. So it brings the highest active process up to the top of the list. And there's different arguments that you can use with the top command to sort this based on CPU or memory or process ID or user, and you can kind of filter through this. Top's one of those things that's really great to just run the top command, but if you get in a little bit deeper and learn some of the tricks, top can really help you dig down very quickly into what's actually going on with your system. Scott?
So, Eric, I'm gonna blow your mind. You said this is very similar to PS output. Well, guess what? It's actually PS output, because that's
fair.
where top gets that information, and then it sorts it by default based off of the percent CPU, and then it secondarily sorts it off of percent memory. So if two things have the same percent CPU, it'll look at the percent mem to decide which one should be bubbled up more towards the top of that output. And then also it bolds the runnable processes. So you'll see those with the R, they'll be bolded as well. And yeah.
Awesome. So I think we're at time, and I think we've let's see. We did actually have one question. Let's go ahead and address this real quick. What would be the correct way to ensure that a service execute during shutdown in any manner? The answer is too long. Best source for documentation. Looks like the heart of the question is, how do you ensure that a process exits cleanly when you're trying to do a shutdown?
So good question. There's not a great one size fits all answer. So when the system is shutting down, it goes through and executes all of the basically a stop across all of the services they're running. And if you look at the system target for shutdown, you'll see the calls to the different services and that they should be stopped. And if you looked at the actual service units, there would be a description in there on what should occur when we are shutting down that service. So if there's any special things you need to do for your specific service, you can put it in the systemd unit file for a stop, which will handle those special cases. At the end, when we think we have shut down all the things, there is then a kill all issued, which will do a kill across all the remaining processes. And that's how we clean up those ones that maybe ignored a terminate signal, or maybe didn't have a description of what we should do to shut them down in their systemd unit file. So that's how we kind of hit those last few. So if you're in that state where you've got a custom service that you've made and you have neglected to put in a section of your systemd unit on what should happen at shutdown, that might be what you need to investigate. And so for that, I would refer you to the systemd documentation, and specifically for writing systemd units so that you can do specific things for your process when shutting it down. I think that's the question. I think that's what they were getting at.
I think so too. And if not, that actually brings up a great point. We are at time for today, but we definitely check the comments for this. Like we've alluded to, this is our first week. This is episode 4, so we're still kind of tweaking things. I think we've got a great flow going here. So if you have any comments, any questions, feel free to put those in the comment section of this video. And then join Scott McBrien. I will try to be there tonight. We'll see if my voice holds out today. But if you want to join Scott McBrien tonight for Into the Terminal After Dark, we might get in trouble for that one. But that'll air tonight on YouTube and on Twitch. And then Tomorrow, I think we did find out we actually planned a topic and pat ourselves on the back. Like, good job, we actually did the thing. Tomorrow we're covering SSH. So how do you connect remotely to a system, and how do you manage how do you secure those connections? But until then, I think that pretty much does it for us for the AM session of Into the Terminal. Be sure to follow us on Twitter, subscribe to our YouTube channel, do all the things, and I almost said keep on coding, but that's a Command Line Heroes thing, which is a great
So
podcast by Red Hat. So go check it out.
I saw a last minute question from Shane. Shane, go ahead and put that in the comments and we'll answer it there.
Yeah, that'd be a great question to we can follow up when we've got a little bit more time to address it. But Scott, thank you so much for joining me today and for kind of carrying the show. I'm trying to make it through the day, but thanks for carrying and I learned a couple of things, so this is great for all involved. All right,
Thanks,
folks,
Aaron.
we'll see you later on today and tomorrow. Have a great night.